So making the web POSH is just a bit of a buzzword, and part of that is I knew I wanted to talk about in-place resource optimization and page speed, but we didn't exactly know what we were going to call it when I was putting in the proposal for this talk. And we originally thought maybe it was going to be called page speed on shared hosting. But actually, our favorite buzzword now is just IPRO, in-place resource optimization. So I'll talk a little bit in this talk about what that is, how it's different from other forms of web performance optimization, and what it does and doesn't do for you. And hopefully we'll be able to dive fairly deeply, and you'll have a nice understanding of this by the time we're done. All right, so why am I here talking about in-place resource optimization? Mod PageSpeed has been out there for 3.5 years now. There are other web performance optimization solutions out there. Why do we need this sort of in-place resource optimization stuff, and why did we sort of decide to add it to PageSpeed after initially deciding we didn't want to do that? Well, the answer is automatically rewriting web pages, especially changing URLs on web pages, can break JavaScript code, right? Any change to the contents of the page, any change at all to the contents of a web page can be detected with sufficiently weirdly written JavaScript, right? You can do things like count the number of bytes that were on the page, count the number of bytes in the various image resources on the page, check that certain bytes are what you expect them to be. Now, people mostly don't write code that way, right? But they do other things that, where when we alter a page, they're very easily detectable using JavaScript code. And I'll show some examples of that later on in the talk. The corollary to this, of course, is doing a perfect job of web performance optimization is impossible. There's always going to be a risk that any automated web performance optimization tool you use can break your pages, unless your web performance optimization tool doesn't alter your pages at all. And that's what we're going to talk about here. In-place resource optimization is optimization that doesn't change your web pages at all. Now, the nice thing about this corollary that web performance optimization is impossible is it's kind of the full employment theorem for people like me, right? There's always going to be more work for somebody like me who works on web performance optimization, because we're never going to be able to do a perfect job. Okay, so how does rewriting break JavaScript? Well, we can have introspective JavaScript, and this actually occurs quite a lot. You'll have a script that, in order to sort of decide what it wants to do next, it looks up the source element of its script tag. Let's say it's a lazy loader that's going to inject a bunch of resources into your page, like it's a loader for a bunch of other JavaScript, or it's a loader for a bunch of specialized CSS files, or it's a loader for ads. So it's going to look up the source element of its script tag, use the URL it finds to create a whole bunch of new URLs, and then insert nodes into the DOM to load those new resources, right? And the moment we go through and we change the source of this JavaScript tag, we can suddenly break the entire universe. It can fall down around us. Now, that may depend exactly on how the script chooses to look up its source element, and it might depend exactly on how we choose to rewrite the URL. So some of the time it works, a lot of the time it doesn't. And in fact, in Mod PageSpeed, we go through and we try and detect when JavaScript does this introspection. And actually, we try and make sure we never change the URLs to JavaScript that's looking like it's performing introspection on its own URL. But that's tricky, right? We don't get it every time. So another common thing we run into is URL mangling in response to user action. The classic bug we have here, and this was filed by my colleague, Brian McQuaid, who works on the PageSpeed Insights team, is we had a website that looked like it worked perfectly with Mod PageSpeed. You could go through, you could interact with it, it was all great. And he said, actually, no, this page is broken. Can you tell why it's broken? And we said, no. We pulled up the original page. They're like, they look exactly the same. He said, hover your mouse over that element over there. You hover your mouse over the element, and the image changes, except in our page it didn't. Because what was happening was JavaScript was adding an extra dash hover to the URL of the image source. And we weren't dealing properly with that. And finally, we noticed that there's actually quite a lot of JavaScript out there. And I consider this sort of badly written JavaScript, right? That tries to locate nodes in the DOM of the page, by matching on the URL. So it'll iterate through, let's say, all of the image nodes on your page and ask, does the URL look kind of like this? And then it will do some stuff. And really, we probably should be setting an ID or a class on those nodes. If we're just looking for one node, we should set an ID. If we're looking for a collection of nodes, we should be setting a class on those nodes. And we really shouldn't be using the URL as a key, because the moment we say restructure our site, everything's going to break anyway. So it's not only bad for us as web performance optimizers, in some sense it's also bad for the site in that it's actually makes maintenance of the site more brittle. Okay, so rewriting can break JavaScript, so let's not change the HTML at all, right? There's still a bunch of optimizations we can do. We can recompress the images. We can minify the JavaScript. We can minify CSS. We can make sure compression is switched on, right? That was sort of point number 2 in Josh's keynote this morning. And we sort of put a label on that, and we call that in-place resource optimization, or IPRO. Right? So when I say IPRO in this talk, I mean do this stuff. All right, so that's great. So we're not changing the HTML at all. Do we get any benefits when we do that? Absolutely. So one of the biggest savings we get in mod page speed is savings in bandwidth. And so this is a graph of all the images in the Alexa top 500 websites that we didn't resize, because we also have a resizer. And we've taken them and run them through the mod page speed pipeline. And we've enabled WebP conversion, so we're fetching these with a Chrome browser. So this is sort of the best case for us. And we can actually eliminate 52% of the image bytes in the Alexa 500. Just by optimizing those resources in place for the specific browser that's fetching those images. Now, if your browser is not WebP capable, we can't do quite as well. WebP images are actually quite a bit smaller than the equivalent JPEGs. But we can serve both WebPs to WebP-capable browsers and JPEGs to JPEG-capable browsers, and we can do that even for this in-place resource optimization. So if we are serving JPEGs rather than WebPs, then this number is going to be more like 30% savings rather than a 52% savings. But 52% savings is great, right? We're saving 460K of download and about half of the bandwidth of fetching a page just by doing this in-place resource optimization. Right, so that's a huge amount of the bandwidth savings. That's pretty much all of the bandwidth savings that we're realizing using mod page speed is right here. Right, so that's great, right? You're done. IPRO works great, and you can turn it on in page speed 1.8. We have this optimized for bandwidth level, and you can enable this prioritized critical CSS filter, and everything will work wonderfully. So, however, there is a small problem. Let's see what the small problem is. So it's World Cup time, so I thought I might use the FIFA website, but it turns out FIFA actually has done quite a good job with web performance optimization on their website. I was suitably impressed. They've actually, they're doing a lot of lazy loading of their images, and most of their images are already sort of maximally compressed down. So instead, here we have, in a nod to my colleague Matt Atterbury, who's an Australian, and because I was putting this together during the Netherlands versus Australia soccer match during the World Cup, we have socceroos.com.australia. And this is the Australian soccer team soccer fans website. So the original one on the left is when I just fetch from Socceroos. IPRO is when I turn on in-place resource optimization. And then IPRO plus optimization means I've re-enabled all of the page speed optimizations that can rewrite URLs. And I'll talk about why we have both that and IPRO switched on at the same time later on in the talk. But those are the three categories for the moment. So let's see how they do. So I'm fetching this from the US, and it's a site in Australia, so it's not the fastest fetch time. and I'm fetching it over not a great bandwidth connection. But you saw when I turned on the optimizations, we were able to download the page in about 6.7 seconds, whereas it took about 10 seconds, and it took about the same amount of time for both the original and the IPRO optimized page. Okay, sorry. So what I want you to take away from this is, yes, turning on in-place resource optimization gets you almost all of that bandwidth savings. But it gets you actually very little of the actual optimization, the speed up, the perceptual speed up that people will get when they visit your site and ask, how long does it take me to be able to interact with your page? So optimize your resources in place to save bandwidth. Definitely do that. But also rewrite pages and URLs to make them faster whenever that's possible, because bandwidth is not equal to speed, though it can really help in some circumstances. It's very clear that in other circumstances, it doesn't really make any difference at all. So this is a slide that I've used before and really sort of talks about the perceptual reasons for speed. I think probably most of us here at Velocity have seen some version of this slide in somebody's talk in the past, and I blatantly stole images from Strangeloop on the left. But the basic idea here, right, is we have this goal that we want people to be able to interact with the web in 1,000 milliseconds or less. And that's sort of our aspirational goal. And you saw on the Socceroos website, even after I switched on all the optimizations, it still took me 6.7 seconds to be able to interact with that website. Right? So we're not there yet. But if we're going to get there, there are some things we're going to have to do to our pages to speed them up. And there are things we should be doing along the way, even if we don't think we're ever going to get to that 1,000 millisecond target on our current website. It's still worth trying to pursue it. So what do we get by rewriting URLs that we aren't getting by doing in-place resource optimization? So one thing we're getting, and this actually really is mostly a bandwidth savings, but it can be very big, is resizing images to their context on the page. So this is an example from our examples page, but you've probably all seen this in sites yourself. Here I have this 1024 by 768 JPEG, puzzle.jpg. And I've resized it to 256 by 192 by just putting a width and height attribute in the HTML. Right? So as you can imagine, a 1024 by 768 JPEG is pretty big. And it turns out when I reduce an image by a factor of 2 in each direction, I roughly reduce its number of bytes by a factor of 4, right? Because it's got 1/4 the area. And in this case, I'm reducing it by a factor of 4 in each direction, so it's roughly 1/16 the bytes that I need to ship down the line if I resize that image to exactly match its size on the page. And so that's one of the things we can do when we can rewrite the URL. Right? We can't just do that in place, because this puzzle.jpg URL might occur in other contexts on other pages where it actually appears full size. Right? So we can't do that, but we can resize it for this particular page if we know its context. And I'll say, by the way, Josh Morantz there's now this whole new question of, well, what if my pixel density is higher than my CSS pixel size? What about retina displays and so forth? And I'm kind of glossing over that on this slide. But Josh Morantz at 3:30 this afternoon is giving a talk on exactly that subject. He's going to talk all about adaptive sizing of images and how you can do them in your site, and how we're thinking about doing them in page speed as well, because the support for that is just coming online in browsers. So there are definitely some complexities here, but one thing I want you to take away from this is that if you can size your images appropriately for where they're appearing, you can save yourself a lot of bandwidth. Okay, so the second thing we get if we start rewriting the URLs of resources is we have the ability to include this content hash in the URL. And So on the left-hand side, we have that puzzle.jpg again. And on the right, you can see, this time I'm not rewriting the image. I haven't even optimized the image at all. I'm just trying to extend its cache lifespan to 1 year. And you can see I've done that by just adding a content hash. So now, if I want to be able to change my website, I can do that. I can change the contents of the puzzle.jpg URL, and the content hash will change. And so people browsing my pages will get resources with a new content hash and will download the fresh resources. But until that happens, they have these resources with effectively infinite lifetimes. And in our case, we set it to 1 year because 1 year seems to be long enough. And we're a little bit uncomfortable with infinity as a concept. So. A third thing we can do is actually combine together multiple resources to make a single resource. And the classic example of this is image spriting, right? I'm not showing image spriting on this slide because it actually gets very fiddly to display. And if you've ever done image spriting, you'll probably agree. I see some nodding heads in the audience. But we can also combine together CSS files, and that's in the purple here. And we can combine together JavaScript files into a single script object. And that reduces the number of connections required to obtain resources. And the resource data comes in over warm connections a lot of the time. Because what happens is, by concatenating the resources together, we are able to use that sort of that IP pipeline, that TCP pipeline, long enough that it actually warms up and we start getting the full bandwidth out of it, because TCP pipelines slowly ramp up in bandwidth until they reach essentially their share of the bandwidth that we get, right? And so we want to be in that steady state, and we want to use them in that steady state. And in fact, that does make a difference, right? So if we look at a web page test waterfall for that page, right, here's before at the top and after at the bottom. We can see those green arrows are the CSS, and they've been combined together in a single file. And it looks like we got lucky here, and the single file didn't take very long to fetch. And part of that is because we're only establishing 4 connections to the server. So those longer bars are because we're waiting for the previous resources to be fetched before we fetch the new ones. And then similarly, in the pink, we have the JavaScript resources. And again, those JavaScript resources are being combined together. And at the very end, this purple bar is, it turns out the CSS has a CSS image in it, and that's us fetching the CSS image. And you can see we have to wait until we have the CSS before we can fetch the image. All right, last but certainly not least, once we can rewrite URLs on the page, we can actually eliminate URLs from the page as well if we want to. And by that I mean inline resources or get rid of them entirely. And by and large, we don't get rid of resources in mod PageSpeed because we feel it's a little bit dangerous to do that. Often we don't quite know what the JavaScript code is doing. But if you're managing a site, the easiest way to make a resource fast is to remove it from your page, right? So here we have, again, all 3 kinds of resource, right? We have a style sheet, we have some JavaScript, and we have an image at the bottom in green. And in all 3 cases, it's very easy for us, if those resources are small, to just simply inline them into the page. So here we have inlined those resources. I should point out here, if we look in the waterfall on the previous chart, right, we see that it takes a certain amount of time to download the HTML. And once we've downloaded the HTML, we don't have a whole lot of time. If we want to achieve that 1,000 millisecond aspirational goal of getting our page to be interactive after 1 second, we don't really have a lot of time to do that, right? And as soon as we sort of add in the time to fetch the resources, we've already exceeded our deadline. Right, so if we're ever going to achieve that aspirational goal, the only way we're going to achieve it with the current technology we have on hand, without some sort of miracle networking technology that gets us infinitely fast speed up on our TCP connections, which is not going to be gotten by more bandwidth, So the only way we're going to do it is by inlining resources into the page. That doesn't mean we should inline all our resources necessarily, though we've certainly talked about that, and we hope to be able to tell you something about that in future velocities. But it does mean that we need to be at least selectively inline some stuff on pages if we're going to make them go quickly. So just inlining little resources is a great start, and it lets us get this nice fast waterfall here, where we've taken those resources, inlined them, and now basically we've added like a few milliseconds to the page fetch time. And we still have to wait for this CSS image to come in, because we didn't rewrite that one, right? You can see there's a CSS image on the right-hand side there. But we're doing pretty well here, right? We're not quite at 1 second, but we're definitely getting closer here. All right. But inlining doesn't stop with just inlining small things on the page, right? What we really want to do is we want to inline the content that's going to be really relevant for actually displaying our page to users. And that means, among other things, inlining the CSS that's actually used by the page. I think a couple of speakers so far this week have talked about this question of how much of your CSS are you actually using on your pages, and how much do you actually need to load the page initially versus need for JavaScript interaction after the page is loaded? And so what I want to stress here is if you have CSS, first of all, you should be putting your CSS at the top of your document as much as you possibly can. Second of all, CSS imports are a bit of a problem, right? Because in order to discover that we have CSS imports, we first have to load in your HTML page and parse it to the point where we know, oh yeah, I've got to fetch some CSS. Then we've got to load in that CSS and parse it to the point where we're like, oh wait, there are CSS imports there. And then we can start downloading those CSS imports. So we add this serial bottleneck to downloading your CSS. So there are a couple of things that inlining can do for us here, right? We can figure out which CSS is actually used on the page, and we can inline that onto the page. And when we run into imports, CSS imports, we can actually flatten those and inline those into the original CSS file that imported them. And when we combine those together, and I did a talk on this at Velocity New York last fall, when we combine those together, we can actually substantially reduce the amount of download time that we take on a page like this one, right? So here's the initial time where you can see we have all these green bars where we're downloading the CSS. And then the second row of green bars, those last two green bars there, are the ones that are two of the imports that we don't get to download until the previous downloads have completed. And then that purple thing turns out to be a CSS image that's referred to in this rewrite CSS images CSS file. And this gets us first render of the page in 1.8 seconds. Again, this is a tiny page, right? Your page is probably considerably bigger than this. It's going to take considerably longer to do first render. But once we inline the most relevant CSS, which is what we've done here, now we don't have to do any external CSS fetching in order to display the page, right? And the consequence here is there are still some green bars because what we're going to do is we're going to lazy load the rest of the CSS when we get to the bottom of the page. But we're going to do everything else first. So we're going to load that CSS image. We're going to load the images on the page first. And then we're going to lazy load the CSS. And in fact, the first render of our page now is at 0.7 seconds, right? We didn't need to download any of that CSS to do the first render of the page. And we can only do this because we can inline those resources and because we can move the resource loads around on the page. And we can only do that if we're allowed to alter the contents of the page. All right. There are a few other important optimizations that inline that I'm not going to talk about in as much detail today. The first one is we actually limit image inlining to images that occur above the fold on the page. It actually doesn't save very much to inline an image that doesn't appear on the initial page view, because what's going to happen is it's going to be downloading while the user is looking at that first page worth of content and before they scroll. And our our lazy loader and many other lazy loaders as well are sensitive to scroll events. So as soon as you start scrolling the page, we'll start pulling those resources in if they're not already pulled in. The other thing I'm not going to talk about in depth today, but I talked about last fall in New York, is that when we have very large images that occur above the fold on our page, again, it's going to be very hard for us to sort of hit this aspirational goal of displaying the relevant content as quickly as possible, right? Because we're going to be waiting for these large images to download. And so what we can do is we can actually inline low-quality versions of those large images that are above the fold, and then lazy load the full resolution version and swap them out when the lazy loaded version has arrived. And the low-res preview can be dramatically smaller. And if you understand a bit about how JPEG compression works and so forth, it's very easy to sort of do 8-fold downsampling on an image and make it 64 times smaller, for example. So low-res preview images we can make small enough to reasonably inline in our document, because we don't want to inline a full-size, let's say, 100K or 500K image onto the web page. That's just going to delay the amount of time it takes for us to figure out what's below the fold on the page and start loading that. I mentioned inlining CSS imports into the file in which they occur. That reduces the serial dependency for browser fetching, right, and helps speed up our page load. And the other thing we can do is we can inline images referenced in CSS files. Now, it turns out, and there was a good mention of this yesterday in one of the talks from the woman who works at the Khan Academy. It turns out this is not necessarily a big win. And it's very surprising, and it has to do with details of exactly how the browser fetches images that are referenced in CSS files. But it turns out those are reasonably low priority, and by inlining them, we actually mess with the way they get prioritized and actually slow the page down. So by and large, we're actually pretty reluctant to inline images that are referenced in CSS files unless they're quite small. This can actually be an issue for you if you're, say, using image spriting or using CSS images in order to display large images on your above-the-fold content, right? There's always going to be this serial bottleneck where we have to parse the CSS before we can start fetching those images. And we're generally better off having those images be outline rather than inline for browser reasons. So that's going to sort of bottleneck how long it's going to take for your browser to get that stuff up and displayed. My hope is that this will get fixed in browsers and we'll be able to stop giving caveats like that in a year or so. So the final thing I'll mention is that mod PageSpeed actually is able to do a lot of these things automatically, but you can easily do many of these optimizations by hand, right? If you understand the structure of your site. For example, if you have a PHP-based site, it's very easy to do CSS inlining if you're willing to inline all of your CSS by simply splatting the content of your CSS files directly into your HTML as PHP is generating it, right? So there are ways of implementing this that don't require you to use a web performance optimization solution. But I will say there are some things that we can do with a web performance optimizer that are actually very difficult to do if you're rolling it by hand. And one of them is figuring out exactly what stuff is on the screen when people first look at your page. So it's very easy to mark your pages up by hand. You can go into a lab and say, yeah, okay, this stuff is usually above the fold. So I'm going to mark that this stuff is important, and I'm going to prioritize it and generate my pages that way. But mod PageSpeed is actually able to do this by gathering real user data and making those optimizations based on real user data. And in fact, that for above-the-fold images, that's just on by default nowadays in mod PageSpeed. If you turn on core and you turn on prioritize critical CSS, then you'll also be getting prioritization of the CSS rules as well, and the inlining of your CSS rules on the page. And again, that's all based on instrumenting the page and figuring out which rules are actually relevant. Okay, so you've looked at this presentation and you've said, okay, that's great. My pages are okay with having their URLs changed. I've done all the right things in my JavaScript. No problem. Go to town. Do I still care about in-place resource optimization? Well, probably. So here's an example. A lot of people use lazy loaders, or even more commonly nowadays, there are image scrollers at the tops of pages, right? And most of these lazy loaders and image scrollers work by downloading stuff using JavaScript code, right? They don't have a bunch of hidden... I've seen ones that just set up a bunch of hidden divs on the page, and then the JavaScript code simply selectively unhides the divs. But by and large, that's not how most lazy loaders work. So web page optimization, we can only do this optimization on stuff that we can see. So on this page, we have this thing where we've set up a lazy load script, and we have an image, and we've set up this data source attribute. And our lazy loader is going to go through and basically replace data source with source when it's time to load the images. So can we tell that that is an image URL if we're just looking at the HTML of the page? Could be anything, right? I mean, if you or I look at it, we say, oh, it's called data source. That probably means it's going to eventually be the source of this image. But an automatic web page optimizer isn't that smart, right? But it turns out we actually do have a way of telling Apache and Nginx, of telling mod page speed, that certain attributes of HTML are referring to image URLs or referring to hyperlinks or referring to other kinds of resources. But that only works if it occurs in your HTML, right? If there's a link in your HTML, this works great. What about something like a dynamically loaded comment section? And I got this off the JS widget easy comment web page, but there are lots of comment widgets out there. This one just happened to be simple and easy to find. And the basic idea here is, right, the only indication that anything strange might be going on is we're loading a bunch of scripts at the top of the page that are going to load our comments. And then down at the bottom of the page, we have this div with a very special ID, and that's styled to set aside a region for the comments to go into. And otherwise, our tool can't see anything in this dynamically loaded section, right? All it sees is, oh, there's a div here. However, we're running on the server, right? So we are eventually going to see some dynamic requests for this ec comment.php here that's actually downloading the comment data in JSON format. And we eventually also see this load of this comment image, which is going to put up a little image next to each of the comments on the page. And you can imagine this is something like downloading all the user pics in your comment section, right? So we can't see them on the page, so we can't change the URL, but we can see them as they're flowing out of the server, so we can optimize them in place. And in fact, if we look, it's still a bit of a challenge, right? Because if we look at the JSON file that comes down, the JSON file actually contains this mixture of JSON, and then there's this quoted stuff that turns out to just be HTML, right? And we can't tell that that's HTML, and we can't optimize it like we optimize HTML, because we have no idea if JavaScript code is going to take that HTML and completely muck around with it before it actually injects it into the page. So we don't know that that stuff is safe to rewrite. Yet. Maybe someday we will. So we can't tell the embedded strings are HTML, and we can't optimize those. But we can still minify the JSON if it's already minimal. And we see the load of those user pics. And so we can still optimize the images in those user pics in place and save the bandwidth that they consume. All right, so how do we go about measuring this on our pages? Right, so here's that Socceroos example page that I showed you at the start. I showed you the animation. Here's the actual page. So I've got this page in hand. How do I go about figuring out which aspects are actually going to help me the most, and what benefit I'm getting from different parts of page speed? So what we can do is, mod PageSpeed actually has an experiment framework. And the experiment framework, by and large, is out there so that you can set up dynamic experiments where you can do ongoing monitoring of your site with different page speed options. So classically, one thing you might do is say, take 1% of my traffic and turn off the optimizations. And that's sort of the canary in the coal mine, so I can tell if my optimized page for some reason is going slower than the unoptimized version. But another thing we can do is we can actually have 0% experiments and set up settings for our server that we're only using when we're testing manually. And the way we do this is exactly like this. We can set up an experiment spec, and basically that says, here's the configuration, because the configuration is going to be different than the normal default configuration that everyone else is going to get. And the %=0 means if someone comes to our site without a cookie, we're not going to give them a cookie telling them to join in this experiment. And in this case, I've set up 2 experiments, one for in-place resource optimization, and the second one is for all of our core optimizations plus in-place resource optimization, plus prioritize critical CSS, and plus deduplication of inlined images, which I haven't talked about much today, but it's another of our inlining optimizations. So once I've set up that 0% experiment, now I can go to web page test and I can tell it to add a cookie to my requests. And that'll tell web page test when it's fetching my pages to fetch them from that experiment bucket. So this one says page speed experiment equals 1. And if we look on the previous thing, ID equals 1 here means run this experiment using in-place resource optimization. And so I run this through web page test, and I get some nice results back. And in this case, when I do the experiment with in-place resource optimization at the top and with normal optimization at the bottom, I get absolutely enormous. I haven't shown you anything like the entire waterfall here. But you can see we have this sort of 20-second on-load time with just in-place resource optimization. And that goes down to 17-second on-load time when we turn on our full optimizations. Now, you saw earlier we were actually getting more like a 6.7-second above-the-fold display time, and that's because we can actually display the above-the-fold stuff down there roughly near the purple bar. We don't need to wait until on-load fires for the page to be usable to people who visit it. And the other nice thing is now we also get these, you can actually see that effect here on this flow. And what you see is if you look at sort of that yellow region in the bottom right corner of the page, the top is unoptimized, the middle is in-place resource optimization. And you see those are pretty similar. The in-place resource optimization is pulling in these images a little bit faster than they were being pulled in without the optimization. But at the bottom, we're already done with the page right here at 7 seconds. So just to wrap up, optimize your resources in place to save bandwidth, but don't confuse bandwidth with speed. Bandwidth can help with speed, but bandwidth is not the same thing as speed by any means. So rewrite pages and URLs to make them faster. Thanks very much. I'll take any questions.
I think we have time for one question. Okay. Can you go back a couple of slides? Just curious about one of the optimizations. The waterfall. Yeah. In this, the resource 14 and 15, when you compare, you converted one of the logos into a WebP, but not the 15. Is there anything odd? What determines? Like both are PNGs to me, looking at this waterfall.
So that sort of gets down into the weeds, but you're absolutely right. Very small images are often smaller as pings than as WebPs or JPEGs. And that's when you start getting images that are small enough that like the headers on the images and the image data itself are sort of comparable in size. Right, so what probably happened there is we tried to convert it to a WebP and we're like, yeah, this isn't any smaller, so let's just keep it as a ping. but well spotted. Another interesting thing that happened here, I don't know if you noticed, that top one has 2 green bars. The green bar at the top has disappeared because we've inlined the critical CSS here, and that's one of the things that's making this page load so fast, or appear to load so fast. And then the bottom, there's this fonts.google's APIs CSS that we're still downloading because it's third-party, but it actually turns out there's another filter in mod pagespeed that I didn't enable for these experiments that can inline the Google Fonts CSS specifically, because we know that font loading is actually a dramatic bottleneck for pages, and we want to be able to speed pages up as much as possible by getting that CSS onto the page. Any more questions? There were a couple over there, I think.
Yeah, we're actually out of time now.
We're out of time?
Sorry.
Okay, thank you.
So if you have more questions, you can
I'll
catch
be
them
at
outside or something?
I'll be at the Google booth during the next break. You can absolutely come by there and ask me questions. And I know my colleague Matt Atterbury there will also be talking a bit more about some of this in-place resource optimization.
Thank you. Please don't forget to rate the session.